Welcome pre-cal students to class today on this Friday, May 8th. Hope you guys are doing well. Hope you're ready to learn some math today. There will be a test on Monday. You should know that by now. So review sheet on Friday. By the way, let me go ahead and jump down to announcement number 3. If I were you guys, I would not work on the review sheets until Monday, and so I don't blame you for doing that. If I was in your shoes, I would do the same thing, but it's really not necessary for me to email out the review sheets if you guys are not going to work on them over the weekend. So what we'll do is, if you want the review sheet, please don't hesitate to email me. I have it all ready for you, and I can email that to you in about 5 seconds. So if you want the review sheet emailed to you, just email me and let me know, okay? So anyways, test on Monday. If you're not going to make it over to the house, please let me know by Sunday. And then please stay on top of your integrity sheets. Whatever you don't have done when you walk on the door Monday, you cannot finish up. So please keep that in mind, okay? Very important that you do your homework and stay on top of it. Okay, let's quickly review what we have studied this week. You should be able to take expressions like this and expand them. Okay, if you cannot do that, you need to review that. You should be able to take problems like these and use your latest 3 logarithmic properties right here, and you should be able to solve these. Okay. You also should be able to take some given logarithmic numerical some answers here, and then solve other logarithms by using logarithmic properties and this information right here. You should be able to solve exponential equations. That's what we did yesterday. Okay, so that's what we've done this entire week. If all of that does not look familiar, then you really need to check on your notes and get back into your videos and make sure you're caught up. Okay. All right. As I mentioned to you yesterday, we are going to finish up the week learning how to solve some new types of equations. Yesterday we looked at exponential equations, and today we will be studying logarithmic equations. Your heading today is solving logarithmic equations. The lesson number is 4.5, and the date today, if you'd like to keep track of that, is May 8th. May 8th. Okay? All right, first of all, logarithmic equations are easier to solve than exponential equations. So that's the good news. We got the harder stuff out of the way, and we have the easier stuff left to solve today. So that's the good news. Okay. Like exponential equations, I cannot really give you steps, but what I can give you is a little more structure, or a lot more structure, when it comes to solving logarithmic equations. And this will make solving them a little easier. The more structure and guidelines I can give you, then the less creative you have to be, and the easier they are. Okay. Here are some goals. We're not going to call them steps. We're going to call them goals that will help you solve logarithmic equations. Okay, goal number 1, condense both sides of the equation so that there is only one log on, and that should be on each side. Okay, so condense both of the sides down so that you have one log on each side. Step 2, after you're done condensing both sides, listen to this. If there's only one side with a logarithm, then write the equation exponentially and solve. However, if there are logs on both sides, then cross off the logs, set the arguments equal to each other, and solve. Now you only do this last sentence right here after you have first done what? Condense both sides. So you condense both sides like goal number 1 said here, and then if there's a log on both sides, then cross them off and set the arguments equal. I'll explain all this to you later. And then if there are ever terms that are not logarithmic terms, you want to get those terms on one side by themselves and all of the logarithmic terms on the other side. That's something also to keep in mind. So these are not steps. You don't do this first, then do this, then do this. These are just 3 things to keep in mind that will help you solve these equations. Okay, so well, what are we waiting for? Here we go. Let's get this done and get the week over with. Okay. We have 4 problems to look at, so this will be a relatively short video. I think the homework video is rather long. It's about 35 minutes long, but that's fine. Nothing unusual about that. And so let's get into this and solve these 4 problems. Here we go. Okay, log base 3 of x equals -2. Now, one thing you want to do is condense both sides down so that there's only one log on both sides. Well, this side over here has no logarithms at all, so there's no condensing we can do. This side over here has only one logarithm, and it's already condensed. There's nothing here to the left. Like if there was a 3 here, then I would pick the 3 up and I would put it right here as an exponent. Okay, but there's nothing like that, so there's really nothing I can do. There's no condensing here, there's no condensing here. So if you'll glance back at goal number 2, it says after you've condensed both sides, if there's only one side with a logarithm, write the equation exponentially. So let's write this exponentially, and what you'll get is x equals -2 to the 3rd power. And that is incorrect. Sorry about that. I do know what I'm doing. X equals 3 to the -2 power. There we go. It just didn't look right. That's why I paused. I was like, that's not right. Okay, so x equals 3 to the -2 power. Now, if you want to write that as a fraction, then you would put 1 over 3 squared, and that would give you 1/9. So x equals 1/9. If you want to use a calculator, which is totally acceptable, then 3 to the -2 power would be 0.1 repeating, 0.1111111, 0.1 repeating, and that's fine also. Okay, so there we go. Problem number 1 finished, and they're going to get a lot harder than this, but that's the first problem. Okay, problem number 2. Now, if you'll notice, the first thing we like to do, not the first thing, but we like to condense both sides down so there's only one log on each side. But if you'll look at goal number 3, if there's ever a term that's not logarithmic, get those terms all by themselves on one side and get all of the logarithmic terms on the other side. And so I do notice I have a term right here that's not a logarithmic term. So I want to get that all by itself on one side. I want to bring this logarithm over to the other side. So that way all of my logarithms are on one side, and then all of my non-logarithmic terms are on the other side. Okay, so it was a negative logarithm, so when I brought it over, it became a positive logarithm. Okay, now there's no logarithms over here I can condense, but I can condense these two. Notice there's nothing to the left and there's nothing to the left, so that's good. They're both base 10, so that's good. So we have learned how to take two logarithms that are being added and condense them. Remember, it would be log base 10, and then you multiply their arguments. So if you multiply their arguments, you would get x squared plus 3x. And now you're seeing why it's so important that you know how to do your math, okay? Math builds, and it's very important you stay on top of it. Okay, there we go. So we condense this logarithm down to 1. There, we're done. Nothing to the left, everything's done. Well, if you look back at your steps, it says after you've condensed both sides, if there's only one side with a log, write the equation exponentially and solve. So we're going to write this exponentially and solve. Here we go. X squared plus 3x equals 10 to the 1 power. Now, of course, 10 to the 1 power is just 10, and right away you should see you have a quadratic equation. And so I'm going to bring this 10 over and make it a negative 10. So I'm just going to do that, that, and that. So I bring the 10 over and make it a negative 10. Well, if I can factor this, I'm loving it, and I can. What two numbers multiplied together give me negative 10 when added together give me a positive 3? Well, it'd be a positive 5 and a negative 2. So I can definitely factor this, and my factorization would be x plus 5, x minus 2. Okay? Now, what number satisfies this parentheses? Negative 5. What number satisfies this parentheses? A positive 2. So it looks like we have two answers. But students, would you please listen to me, Matthew, Caleb? We really don't have two answers. Okay, and I should have set a better example back here in this problem. Notice we got out 1/9 for an answer in the first problem we did. If you were to put 1/9 in for your argument, that's totally fine because your argument always has to be a positive number or 0. Remember, I've taught you that. I've taught you can never take the logarithm of a what? Of a negative number. You cannot take the logarithm of a negative number. So you always need to check your answers and make sure your arguments end up being positive. Now here we were fine. But over here, look, if you put a -5 in for x right here, you're taking the logarithm of a negative number. So right there it fails. I don't care if it works over here. Now it doesn't work over here, but I don't care if it did. If this number here, if this answer right here gives you just one negative argument, then you can't use that solution. It's impossible to take the logarithm of a negative number. You can't do that. So right away I can see this answer doesn't work. Now, if I put a 2 in here, I have a positive argument, so I'm fine. If I put a 2 in here, 2 plus 3 is 5, and I have a positive argument, so I'm fine. So the answer is 2, but the answer -5, we have to reject that answer because it would not work. It would not satisfy the equation, okay? You cannot take the logarithm of a negative number. Okay, 2 more problems to go. All right, well, this one's pretty similar. I have no logarithms over here. I have 2 logarithms over here. Notice there's nothing to the left, nothing to the left. They're both base 3, so I'm going to condense these 2 logarithms down to 1. All right, so here we go. Log base 3 of, now notice the 2 logarithms are being subtracted, so I'm going to put 2x minus 1 over x minus 4, and all of that still equals 2. Okay, so there we go. I've condensed the logs down on the left side to 1. There are no logarithms on the right side, so I'm pretty much done condensing my logarithms. Now, if I have one logarithm here, I'm going to write the entire expression exponentially. So now I have 2x minus 1 over x minus 4 equals 3 to the second power. And of course, 3 to the second power is just going to be 9. Now, we should know how to finish these problems. We don't like fractions, so in order to eliminate my fraction, I'm going to multiply the entire equation by my denominator, okay? So, if I take this fraction here times this fraction here, x minus 4 will cancel with x minus 4, and I'm just left with 2x minus 1. If I take x minus 4 times 9, I will get 9x minus 36. And now we're ready to solve this. Bring the 2x over, and when you do, it will become a negative 2x. Bring your negative 36 over, and when you do, it will become a positive 36. And now let's go ahead and combine. -1 positive 36 is 35. And 9 minus 2 would be 7x. Divide both sides by 7, and the answer is 5. Okay? Now, keep in mind, and I'm just quickly checking my answer to make sure no mistakes were made. Okay, keep in mind you need to check your answer. If you put a 5 in for here, 2 times 5 is 10 minus 1 is 9, so your argument is positive. If you put a 5 in here, 5 minus 4 is 1, so your argument is positive. So your answer does check, everything is fine, and 5 is the solution. Okay, one more and we're finally finished. Okay, this will be the first one where we're going to have a logarithm on one side and logarithms on the other side. Now, we had one like that 2 problems ago, but there was a term that did not have a logarithm, and so we had to move this logarithm over here to the left side, and so thus we really ended up with all of your logarithms on one side and none over here. This will be the first problem where we have logarithms on both sides. Okay, no big deal. If you remember the steps I gave you, you try to condense both sides. So we're going to try to condense both sides. Over here on the right side, you just have the natural log of x. But over here, we have both their base e's, nothing to the left, nothing to the left, and so we can condense these down to one logarithm. So I'm going to write natural log of 4x plus 6 over x plus 5. Now, here's what I want to show you. Notice we have condensed this logarithm as far as we can go. Notice we have this logarithm condensed as far as it can go. They both have the same base, which is very important. There's nothing to the left and there's nothing to the left. So when you get to that point, you're allowed to just simply cross off the logarithms and set the arguments equal. Okay, so that's what we're going to do for it. And it makes sense because if you want both sides to be equal and you have the same log and the same base, then the arguments have to be equal in order for the equation to be equal. So it does make sense. So there's what we have, okay? So this is somewhat similar to the last problem. We're going to multiply both sides by the denominator to get rid of my fraction. And so I'm going to multiply both sides by x plus 5. This fraction times this fraction, your x plus 5s would cancel, and that would leave you with 4x plus 6. And then if you multiply x plus 5 times x, you will get x squared plus 5x. Now right away, you should see you have a quadratic equation. So let's get one side equal to 0. Let's bring the 4x over and make it a negative 4x. Let's bring the 6 over and make it a negative 6, okay? So bring the 4x over, make it a negative 4x. Bring the 6 over and make it a negative 6. These are totally gone, and we're left with x squared plus x minus 6. Now thankfully we can factor this quadratic, so that will make it a lot easier. If we couldn't, we'd have to use the quadratic formula. Okay, what two numbers multiplied together give me a negative 6? When add together give me a positive 1. Well, that's going to be a positive 3 and a negative 2. Okay, so x plus 3. Now remember, these aren't your answers right here. These are the numbers we use to factor. Okay, x plus 3, x minus 2. So what solution would satisfy this parentheses here? A negative 3. And what solution would satisfy this parentheses here? A positive 2. Let me get a quick drink here. Okay, now listen, students, maybe these answers don't work, okay? So let's go up to the very original equation. If I put a negative 3 in for x, 4 times negative 3 is negative 12, and negative 12 plus 6 is a negative 6. So right away, if just one argument becomes negative, then that solution does not work. And so negative 3 is not going to work, okay? It gives you a negative argument. Let's try 2. 2 might not work, okay? 2 works here. You would have 14, I believe. Yes, 14. That's good. If you put a 2 here, you would have an argument of 7. And if you put a 2 here, you'd have an argument of 2. So we have all positive arguments. So this number does work. So this is the solution. Okay. Now, you know, some teachers go on and teach and teach and teach and give a lot of practice. And that's fine. I'm not criticizing that method. For me, I would rather have you practice while you're doing your homework. A, it's not so boring for you, and B, you're getting your homework done while you're practicing. So I'm not going to give you any more examples. Those are definitely sufficient, and there's a homework help video to help you also, and I think you're good to go. So if you have any questions, don't hesitate to email or call. Your homework is page 408, numbers 27 through 57 odd, and I hope you guys have a good day, and again, contact me if you have any questions at all.